I'm going to discuss the alkaloids. Here, I will discuss natural occurrence, general structural features, isolations, and how to carry out their physiological actions, Hoffmann exhaustive methylation based on the cocaine and nicotine, what is the aimed modifications, and what are the medicinal importance of nicotine, ephedrine, quinine, morphine, cocaine, and aspirin. So let's start our today's discussion. So the presently, what is the alkaloids are all about? Alkaloids are basically naturally occurring substances, and they are being found in different plants as a nitrogen containing compounds. So their basics, alkaline nature leads to the term the alkaloids. They have very diverse and important physiological effects on humans and other animals. Some well-known alkaloids are morphines, then cytosine, quinine, nicotine, etc. And since it is the first identified, the first alkaloids, morphine, which has been found from the opium, that is the poppy flower, and from then onward, there are the 10,000s of alkaloids have been isolated till now. So alkaloids are the active compounds of numerous medicinal plants or plant-derived drugs and poisons, and their structural diversity and different physiological activities are unmet by any other group of the natural product. Although the alkaloids have been detected in some animals, they are the toxic secretions such as the fire ants, ladybugs, and toads, etc. The major occurrence is in the flowering plants only. Alkaloids are relatively stable compounds, and they have accumulated as the end product of different biosynthetic pathways, mostly starting from the common amino acids such as lysine, ornithine, tyrosine, tryptophan, and others. Their classifications is usually based on the formed heterocyclic ring, what types of heterocyclic ring it will have, and accordingly we will classify them. So I am showing it at the very last slide about the classifications. Then alkaloids with the narcotic analgesic properties have found different variety of applications in the medicinal cause, and served as a model compound for the modern synthetic drugs, while several are abused as illegal drugs. For example, cocaine, which have been presently used as a drugs by the youth, as the cocaine, which is being treated as one of the most illegal drugs of the alkaloids family. Other alkaloids are the too toxic for any therapeutic use, for example, quinine and strychnine, but plant constituents are still screened for the new biological active compounds, which have been continuous way of motivation to find the new alkaloids, since they are the many importance in the medical value. An example is the discovery of there's the discovery of Taxol, which is which have anti-cancer drugs property, although it has different cytostatic properties too. Now let's go to the exhaustive methylation. So what the exhaustive methylation is all about. The exhaustive methylation is the Hoffmann process, which has been already been discussed in the earlier part also in the amine. So as you know, that if it's a 1 degree amine with nitrogen, there is a presence of lone pair, which can undergo nucleophilic substitution reactions to form R2NH compound, and that R2NH compound further undergo nucleophilic substitutions with another alkyl halides to give it tertiary amines, which further undergo alkylations or substitution reactions to give an tertiary or quaternary ammonium salt. These particular reactions is considered as the Hoffmann exhaustive methylations. Here, commonly the methyl groups is introduced in the amine, and hence this can be treated as the exhaustive methylations to carry out the structural elucidations of different alkaloids group. Here it is a one alkaloids groups, which is here it is the nitrogen having the two lone pair. The iodide groups will be revolved as the Ki, and here it will be CH3 will be generated, which will be attached to the lone paired group. Since it can undergo methylations with the CH3 group, on methylations it will give a quaternary salt as shown in above, where the ultimate product should be a quaternary ammonium salt, and it should be already nitrogen carbon. There is a 2 carbon nitrogen bond, so there would be possibility of 2 carbon nitrogen bonds, which is shown as below, and on hydrolysis it will undergo E2 elimination reactions in presence of sulfur oxides. So here it is the way this particular, either it will break down the left hand side or it will be on the right hand side. If it is break on the right hand side one, it will generate there will not be any bonds. Have you seen it? And here it will be a double bond. And if it is breakdown on the left hand side, here it is the breakdown. So here it is the double bond. So ultimately these two products will be generated. On further methylations, these particular groups will break down and be here, and similarly it will break down at here, and there will be a new compound which will be diene will be formed, and double bond will be, one will be here and another will be here. So that is the way to carry out the methylations. So here is the questions which has already been asked in earlier questions paper, where it is the given as this is the compound where alkylation should be possible in the nitrogen. 2 alkyl group will be added, followed by hydrolysis, and then it will be break up. One will be break up here, another will be break up here. So this one is the answer. First one is this one. There will be a double bond. Next one will be break up here. So that one will be the product. So this is the one way to denote the further alkylation. So ultimately it will lead to generate a tertiary or quaternary ammonium salt. So alkyl groups will be remained as an alkane or alkene part. Definitely it is the alkene one. Similarly, another questions has been asked where this one is the given, and here it will be the first alkylations, and the first alkylation a particular and followed by the second. So that means the nitrogen will be break down from here. Here to be a double bond, here it will be the double bond. Here is the answer. So here is the first step. On second step, it will be breakdown in the here also. Always you can carry out on the any in. There is no criteria whether it will be takes place on the left hand side or right hand side, but preferably the steric one will be breakdown first. So whichever is the steric crowded, that one will you have to identify here. So since this one is the steric crowded, as there it is a propyl groups is here. So carbon nitrogen bond on the right hand side will be breakdown first, followed by the second, followed by the left hand side one. So here it is the way. So here is one another example where nicotine is asked what would be the product and what it will be look like. So here it is the way. So first I just placed Here it is already methyl groups is here, already one methyl groups is here. So here is the possibility of two CH3 groups can be joined, either in the nitrogen in the here or one will be the here. So this is the way, followed by hydrolysis. Hydrolysis will cross to break down the most steric one. That means this one will be breakdown. So here it is the breakdown. And on further methylations, another groups will be attached here. Then hydrolysis, so this one will be breakdown. So ultimately that one will lead to this product. It is a pyridine, and then this one is the double bond, that is the butadiene. So here's the way. Now the next question, next one is that what is the end degradations? This is also called end reactions or end reductions, is a method for the reduction of quaternary ammonium cation to a tertiary amine with sodium amalgam. Here is the compound which let's consider an alkaloid, which is treated in presence of sodium amalgam. It will be breakdown in the particular carbon nitrogen bonds. Here now it is the here. It will be breakdown. Either it will be break at here or it will be here. So lead to a compound basis. And these types of organic reactions was first described in 1909 by the German chemist Hoffmann, and was for a long time of the great importance in structural elucidations of many alkaloids, for example that of ephedrine. Alternative reducing agent exists for these reactions, for instance lithium aluminum hydride 2. Now one question was already been seen in the previous paper, is that discuss the importance of Hazarika method in the structure determinations of alkaloids. What is the importance? So the importance is that the presence of any N-methyl group means methyl groups which is attached to the nitrogen group, and their members may be determined by means of Hazarika method. And when the alkaloids is heated with hydrochloric acid at 150 to 300 degrees centigrade under pressure, and methyl groups are converted into the methyl iodide. Hence, you can determine whether the alkaloids contain any methyl group attached to the nitrogens of the alkaloids, attached to the nitrogen and heterocyclic ring of the containing the nitrogen. So this is the way how to use the one particular reaction to elucidate a particular structure. Another important question which has been found in earlier paper is that the Jessel's method. So what is the Jessel method? Jessel method is based on the reactions of HI with an methoxy group. When reactions of methoxide, it will be formed an alcohol and methyl iodide, and number of iodide groups will determine the methyl group's presence. For here, if I add silver nitrate, it will precipitate out silver iodide. Based on the number of silver iodide group, you will be identified the number of the groups present. So here it is the part. First point is that the alkoxide groups and sometimes C2H5 occur frequently in the alkaloids. They are the common part of the alkaloids, and these two particular groups can be determined by this method. Here the process involves the boiling of the mixture with HI or hydrochloric acid at 126 degrees centigrade, which will convert the alkoxide groups to the respective alcohol, and hence they will be precipitate out in the form of silver iodide when it is treated with silver nitrate. The number of moles of silver nitrate is used will indicate the number of alcoholic groups in the alkaloids is present. So number of alkoxide groups or say alkyl group present in the alkaloids can be determined. The related group that the methane dioxide, dioxy, estimated on the basis of basis of that, and it liberates formaldehyde when titrated with the hydrochloric and sulfuric acid. Thus, the quantitative estimations of formaldehyde will give number of methylene dioxide group. This one is the exceptional case. So this is the one of the classifications where quinolines should be this one, where it is the quinine, quinidine. So these are the part of the classifications based on the particular group. So if the alkaloids having such types of structure, then it is called a quinoline. If it is having the isoquinoline structure, then it is classified as isoquinoline. If it is phenytoin structure, for example morphine, then it is classified as a phenytoin. So similarly, indole, if it is having indole structure, then it will be classified as the indole. If it is having imidazole structure, then it will be classified as imidazole structure. If a alkaloid is having the such types of compounds, then it is called the purine alkaloids. So these are the classification. For example, if it is here, it is the nicotine. So nicotine is at C, here is the one, here is the one. So it will be either being classified as the pinols and the pyridine. So this is the way to classify. So nicotine is having very important use in the primary therapeutic use for the treating nicotine dependence. Nicotine has been used for several years as in cigarettes and etc. And presently they have used this one to give the patients through gums, dental paste, lozenges, etc. electronic substituents for the cigarettes. So these are the part of where nicotine has been used right presently. This is the eye green, so which can stimulate the salivary gland. So here is the cocaine. So where taken in various ways to make people temporarily happy. Cocaine, this has been presently used as a anti-narcotic drugs. Quinine is also been used as a WHO recommended treatment for the malaria. So presently, as you know, hydroxyquinine is used for the coronavirus. So here is the one of the quinine basic structure. So quinine is there. Quinine is also being used for to treat lumps and arthritis, etc. Here is the morphine. Morphine structure is in this pattern where the 3 rings, so phenytoin rings is here with alkoxide groups. Just try to draw these 3 rings first, then attach the rings here, furan type space, then it is base 1, 2, 3, and amine should be there. Then reserpine is another alkaloid, which is anti-hypertensive drugs, has been used for high blood to control the high blood pressure.